Cool. Hello, everybody. My name is Shay Nehmad. Like Levi said, I met him in San Francisco. I'm actually kind of new here in America. I moved here a year ago from Israel to join a startup. And one of the things I do in San Francisco is I run the Go meetups because I'm way into the Go programming language. Uh, if you're ever in the area, maybe you can look for our conferences. I know it's really far away, and also I don't know how many of you programming Go, but that's how I met Levi. So it worked at least once. You know what I mean? And I thought I could give you all sort of a Git workshop that I've done a few times already in the past. Um, and it's the workshop is should be super fun and pretty simple to work through. I hope you all have laptops. Raise your hand if you don't have one and you need Levi to set you up with one. Also, I need to be able to look at this tab. All right, everybody good? So just a tiny little bit about why we're doing the workshop. And of course, if there are any questions, I don't know if you can drop questions in the chat or whatever, or just yell, whatever works best.
If you get my attention and raise your hand, I can bring a mic to you. So if either of us notice someone raising their hand, or if someone taps me on the shoulder or something like that, you can ask a question.
All right. So does that sound good to everybody? Can we get started? Woo! All right. So why even do this? Oh no, they made the video private. Ugh. Really? Yeah, they did. Never mind. This was a video of people trying to use tools and failing in really hilarious ways, like a guy getting on a jackhammer and falling to the floor. With the point being that knowing Git halfway isn't great. You might cause havoc. Mastering Git is useful beyond using Git specifically. It teaches a lot of useful things about system programming and low level programming and whatever that make a lot of sense. It's not super hard. It's a relatively simple system. And therefore you should learn more and practice Git. And now in the year 2026, I've had to add, yes, even in the age of AI. So in my opinion, I don't know how many of you, let's do a raise of hand thing. How many of you are using Claude Code or Codex or any of its relevant things? All right. Keep your hand up if Claude Code is doing the commits for you as well. You don't type git commit manually anymore. Yeah, I know at least for me it's true. So some people may ask why do I need to practice Git? Claude will just do it for me. I think there's a lot of intrinsic value in knowing how the system is built because it's a really elegant system. And B, I don't think that typing Git commands manually is a great spend of tokens. Also, these tools sometimes do cause havoc. They run git reset or revert or push -force. There are a lot of horror stories online of the agents running amok and doing wrong things. So in my opinion, and sort of the myos of this lecture, which is a message in one short, simple sentence, is that y'all should learn more and practice Git. And this is what we're going to do. We're going to go through a super short intro and brief refresher of the basic commands. Not going to spend a lot of time here. Then we're going to talk about how branching works. And this is going to be an internal view into Git. This is going to be the most of the lecture. And ideally, we'll be able to wrap up workflows and best practices pretty quickly and then jump to the sort of competitive part of this evening, in which you'll try to apply what you've learned and beat my Git CTF. So that's what we're going to do. Before I jump into that, I want to, because I'm not in the room, I want to try and understand who I'm talking to at least a little bit. Who knows what a CTF is? Raise my hands. All right. Who took podium? So at least third place in any CTF. All right. Cool guy at the front with the black shirt. I got my eyes on you. We'll see if you win the Lego set or whatever. It's you. It's you. The guy who's pointing all around. Good luck with that. Oh, is that actually just Levi?
Not.
Levi's over there. Okay. So those of you who don't know what a CTF is, I come from a security background. It's actually a good chance to tell you just a little bit about myself. I started my technical career in 8200, which is the cyber intelligence arm of the IDF, which you've heard about in the news recently a lot. Depending on which channel you're listening to, if it's like Fox News, is that army that you're funding with your taxpayer that doesn't do anything. If you're listening to Democratic, it's even worse. I've been there for 6 years. Discharged as an officer, did technical roles, including low-level programming. And then I did a bunch of startups. Some of the names you may know: Recolab Security, Guardicore, which got sold to Akamai, Orca Security, which is a cloud security startup. Most recently, and in the Bay Area, I've joined an AI security startup called OpsonSecurity.com. And if your company is trying to employ like AI agents, especially enterprise style ones, and you're worried about them doing naughty things, you should check Opsin out. Other than that, I live in the Bay Area. I have a cute kid. She's 5. And luckily, my wife took her out today, so we can spend the entire evening together. No disturbances. Cool. So, short intro. What's the origin story of Git? Like every good superhero, Git has a origin story. And if you don't know, the Linux kernel was developed for almost 10 years with no version control system at all, just like dudes emailing code to one another. And in 2002, they decided to use a software called BitKeeper, which was closed source and not a great culture fit for Linux. They kept like fighting with the software trying to open it up. 2005, they did like a licensing and pricing change, and that's why nobody knows the name Beatkeeper today, because Linus got pissed off and developed his own. And within like 6 months, it was already storing. Git was already storing Git, and then a week after that, it was already storing Linux. Why is it called Git? It's just like slang for idiot. Linux is named after Linus, and he was like, "Oh, I want the other project to also be named after me." What is it? So it's an open source distributed version control system. It's a lot of words, but we can definitely break it up, right? Open source, meaning you can read the code and it's available and has a license, blah, blah, blah. Version control system, oh, it manages versions of things and usually allows people to collaborate. The important part is that it's distributed. That's the part where people's understanding of Git sometimes it gets a little fuzzy. Everybody has all the versions on their machine, including the server, the computer. They're all actually sort of servers. And it's designed for speed and efficiency, and we'll see why in just a second. Like, how did they do that? Since most of you, let me just do another like quick level check. Anybody never ran any Git command at all in the room? Okay, good. Then we can get through the next part really quickly. So you initialize the repository, you type git init, you add a bear to it if you want to make it bear. Who knows what that means? A bear repository.
Someone suggested no readme.
No, it doesn't mean no README, although that's a good idea. it means it has no working copy at all. So it doesn't have like files you can actually edit. It only has the version database. Why do we need one? Because if you don't have a working copy, you can push into it without causing any synchronization issues. So it's really good for servers. To get started with working with a repository, you clone it to your local machine. That's why you first have to clone, and then you check out a specific working copy. And then you have the normal work lifecycle that I'm sure you're familiar with, where you add a file and then you edit it a little bit, and then you add the changes, you stage them as it's called, and then you commit it, and then you can even push it back to main. Some of these slides are pretty old. You can see it still says master. And if you're looking for me to like teach you how to do various workflows, this is less relevant as time goes on. Here's a few like common commands you should know by heart, and also your agent probably knows them by heart at this point. So just feed it one of these cheat sheets. To me, this is less interesting, like the super hardcore tricks. What I want to show y'all is the internals, and like why should I show you internals? Why is it worth your time? In my opinion, the complex air quotes part of Git, scary stuff like cherry picking, interactive rebasing, installing a custom Git hooks, solving tree conflicts, like all these various scary parts, which a lot of times on your teams, like someone will need your help doing. They become really easy to understand and learn if you know the internals. And also, there aren't enough layers for this to be really complicated. It's not like an infinite question, like how does the internet work? Actually, this onion has just like a couple of layers, and when you peel them off, that's it. You're going to see it. It's made up of really simple stuff. So remember how we talked about the repo before? It's actually just a folder called .git, and it has some bureaucracy, but other than that, it does two things, or it contains two things. It contains a collection of objects. I know this is like very abstract, but be with me like just for a few minutes. I promise there's a payoff. It contains a collection of objects under the .git objects folder, and then a system for naming these objects under refs and refs heads. And one advisory, we're going to use commands called git plumbing commands, which are like internal commands for Git. It's almost like in private functions. You can call them in your day-to-day work, but there are the normal commands you're used to using, like git status, git commit, and whatever. The porcelain commands are the ones you should actually use. That's like the user layer. You shouldn't have to use these commands on a day-to-day basis. I basically only learned them because I was interested in for the lecture. I never had to use them on a day-to-day basis. So just be careful that I'm showing you some commands. That doesn't mean that you should like use them. Sorry about that. All right. Let's do a deep dive into Git, shall we? Any questions so far while I'm setting up the screen sharing and whatever? All right. So here's what we're going to do. You see I have my shell here set up with three Tmux panes. And I'm going to try to make this pretty clear what I'm typing. I just want to make sure that you can actually read what I'm typing. Is the font okay, or is it too small?
It's a little bit small. If you could make it bigger. I've also dimmed the lights in here so we can kind of see it better already, but
I'm totally done with you dimming the lights. Just don't fall asleep, y'all. I did this lecture in the army as well, and the moment you turn off the lights, people just.
I can read that from the back. Does anyone else need it bumped up? Maybe bump up a little bit more, if you can. Okay, I'm seeing some people in the back reading that.
All right. Seems like the joke has somewhat landed, so
It has.
you can somewhat read. I hope it'll work. So what I'm going to do is I'm going to create two folders. I'm going to create one folder called remote repo, one directory called local repo. These are like representing repositories. Well, they're going to be actual repositories in a minute. It's just the remote and local verbiage is supposed to emulate, like a GitHub server or something. Although they're both clearly on my machine, right? Now, once I'm in the remote repository, I need to initialize it. So, anybody remembers how to initialize a repository? Yes, but with what
Init.
important flag?
Bear.
Yeah, that's exactly the case where we would use bear. Initialize them to Git repository. Let's see what we have here. Okay, so we have some objects and a way to name them, and a bunch of bureaucracy. Who cares? So now I want to use this repo, right? So I'm moving to the local repo, and how do I start working with that? Well, again, pretty simple. All I need to do is I need to clone it, right? So git clone. Now, usually when you do this stuff, you have, you can see my autocomplete here. You like go to GitHub or another server online and you use HTTPS something, right? But that's not the only like URL or protocol you can use. You can also use the very rare but useful for demonstrations file protocol. Right? It's a protocol. Network and files are the same. Everything is a file. And yep, now I've cloned it, and you can see that my shell has this like, oh, you're on main, and all these nice things. It also gives me a warning that I have appeared to clone an empty repository. Yeah, of course, right? Because that's what I haven't done anything yet. That makes sense. And again, important to note, the local and remote verbiage here may be confusing. This is all on my machine, just two different like folders. Now here, I'm going to do something very, very unhealthy. I'm going to do cd into the .git folder, which you shouldn't do often. Like you shouldn't go here. And I'm going to do something very unrecommended. I'm going to just start deleting random things in this, right? Why am I doing this? Because I want us to do like watch on the repository and see what's going inside my local repository at every given moment. So I'm running a command called tree, which shows like it's like, ls or whatever. But it has a ton of stuff in it that some of it I don't really need, right? So I'm just gonna sort of brutally, let me set this up here. Go into the .git folder here on the left where I'm typing, and I'm just gonna rm.rf hooks and description. Those sound useless. We could probably delete it, right? All right, sounds good. Don't do this. Don't go into .git and delete random things. These two specifically were just samples and some documentation, so it was okay. Now, let's start figuring out what is this. I don't know if any of you are into like security research, but just try and read stuff and see what it does. So let's start with config. I can read the config. It's a plain text file, luckily. And okay, it looks like it has some configuration here. Let's see. Repository format version, whatever. File mode, whatever. Bear, I know that word. This is not bear, right? This makes sense. If you compare it to remote repo config, you'll probably not be surprised that in the remote repo, it says bear true, right? A few other configurations like ignore case, pre-composed Unicode, whatever. You can also see that our origin is configured to be like this folder. And we already have a branch main because that's the default branch when you install Git right now, even though we haven't committed anything. Okay, let's start seeing what these objects and refs are all about then, because the rest of the things here seem pretty empty. Like, right, looking at this tree, doesn't seem like there's a lot here. Let's start creating files. If anybody has a question, just shout. But I'm going to start very simple. I'm going to echo hi into Alice txt. Nothing happened on the left, right? Nothing changed. Let's add it. You can see here that my shell has like this +1 thing, noting very usefully that I'm about to commit this file, alice.txt. But more interestingly, something happened here. So an object has been created. And also a file called index was created. So what's going on? One way to figure out what's going on is to echo hi into our first plumbing command, hash object. And you can see it gives me this like weird blob. Anybody can figure out what's interesting about this hash specifically?
It's the SHA-1 DC hash of the contents of that file, and the first 2 hexadecimal characters are the name of the tree.
I'm not hearing Levi. You're gonna have to bring him the mic.
Can you hear me?
Yes.
One, two. Okay. Talk a little bit louder.
It's the SHA-1 DC hash of the contents of the file you just added, and the first 2 hexadecimal characters are the name of the tree under objects, and the remaining are the name of the...
That's right. So the object is actually named the same as the hash. There's a little quirk here, just implementation quirk. The first 2 characters are a folder. This is just so file systems play with it nicely, because otherwise it's going to be a huge folder with tons of files. And hashes have the, lucky, they're lucky enough that they're uniformly distributed. So you just get sort of easy sort of index, which file systems usually like. And Git, what it did is it hashed the file content, compressed the file content, and then wrote the compressed file content into .git objects. And you'll notice that this path is already in my autocomplete. This is because the hash of the word hi is always the same, and I've done this lecture before. But if I cat it, you'll see it's like some ugly binary content, right? So let's see what's up with .git/index. Oh, you'll also notice, funnily enough, that the compressed content in this case is longer than the actual content. This is like a classic interview question, right? Can I develop is it possible to have a compression algorithm that's always at least 99% efficient? Of course, the answer is no, because otherwise I could just compress the same content again until it reaches 0. In this case, hi is actually fewer bytes than the compressed content. Looking at git.index, it also looks kind of binary and shitty when I try to print it, but it does have at least the words Alice txt, so it is somewhat useful. How can I read it? Well, another plumbing command, which is git ls files ---- stage. If you've ever heard the term, you got to stage a file, you got to unstage a file. Here's one piece where the onion's done is literally just adding it to this index file. That's it. When you stage a file, you add it to its blob and its name to the end, like its mode, to the index file. And when you unstage it, you delete it from there. So here we can see we added a file with some default permissions with this content, again, this object, and this file name. And that's it. After you add a file, what you usually do, you commit, git commit, -m, first commit, St. Louis is dope. Oh, actually, wait, do Springfield, there's hate St. Louis? Is this sort of a San Jose, San Francisco situation?
I think we're meh.
Are we okay? Are we okay with them?
Yeah, I think we'll accept it.
Acceptable. Sounds good. Holy hell! So many things happened in the Git repo, in the Git repo, yeah, in the local folder. The important part is that there are 3 objects now. You'll remember B1, whatever, is the content high, and there are 2 other ones. Now we can, I can do get the slash objects and read it and then rewrite the unhash whatever. But there's a command, cat, like we have ls files, we have cat file, and we can just read the relevant file, and we can even give it just a hash. So let's start with B1 4D. Hi, cool. Let's start with 2.9, and these ones I don't have in my history because they contain timestamps, and the timestamps change all the time, so the hashes change all the time. All right, we have a file here. It contains a tree, an author, a committer, and my message. So this looks like a commit, but what's a tree? Tree sounds sort of like a folder or whatever. Let's just read it. It's the last object. You'll see CD9B there, right? Cat file minus B CD blah blah. Again, I don't have to give the full hash. I can give just like 4 letters and it's fine. This looks like the index, and this is basically the snapshot of the files at the time with a pointer to the content. So we have the commit, which holds a pointer to the tree, which holds a pointer to the content itself, the blob it's called. Now, when I say pointer, don't get confused. It's not like a file system, it's a file system pointer. It's not an in-memory pointer or something like that. Literally, there are files here, and this is their names. And this points towards this file. It's just called an object, so it's useful to think about it as a pointer. So we have the commit, and then we have the tree, which has the permission, the type, right? Permission, type, blob, the content, and the path. And last is actually the file's content, right? This is high. I know some people find the terminal kind of maybe confusing after a while, so I just wanted to show that these are the objects, right? You have a commit, points to a tree, which has blobs, and the blobs point to one another. Cool. Questions so far?
I've got a question. When you did the ls files, what was the 0 after the hash of the... Yeah, what's that 0 after the hash right there? Does that mean anything?
Damn, I don't remember. I think it's like the number of pointers or something like that, but I'll have to double check. But I remember, I never used it, so.
Right on.
It's a good question. Output.
I got another question.
Looks like it's tag mode object stage. Oh, you can have multiple indexes. It's a super unused feature, but you can have, theoretically, you can have multiple stages. So you can do like git add to stage 1 and git add to stage 2. I've never used it, but like the stage of the file which is recorded in the index. Does that make sense?
Yep, and we got another crowd question.
Shoot.
The question I had was, is blob the only type that is used, or because a text file being a blob seemed weird to me? So are there other types besides blob in Git?
Nope, there are 3 types: tree, blob, and commit. So the last one was 2.9df. Commit. These are the 3 types of objects that can exist in the objects directory. Importantly,
actually.
blob, all files, even if it's a text files, are not stored as text files. They're stored as binary blobs because they're all compressed. This is a decision for, you remember how up top I said it's a system designed for speed and efficiency. So having everything like locally and having the directories, the first two letters for file system efficiency, all these little decisions sort of help things be very quick. And turns out that text files normally compress really well. This is a system designed mostly for text files like code, right? So they compress really well. So it made sense to just store them all as binary blobs as they're compressed. This is why also storing like, a video file in Git is probably a bad idea because it doesn't compress very well. Importantly, unlike SVN or CVS or some older, or TFS or some older version control systems that y'all may have used, Git doesn't store the differences. It literally stores the entire blob every time. There are some, like second order optimizations beyond that, but that's basically how it works.
So there
Pretty
is a
simple.
fourth type. There's 4 types. The last one is an annotated tag gets stored in objects as well. A light tag doesn't. It goes into it goes into refs, but an annotated tag, like if you make one, it'll create a
Oh,
it'll
you know
create a
what?
blob
You know what? I thought that annotated tag is a subtype of commit, but I may be wrong. I'll check.
So if you make one, you'll see it pop in there. But if you do a light tag, if you just do git tag version 1.0,
Yeah, that's just a ref.
it'll go into ref. Yeah, but a annotated one has its own blob and it actually, like, the annotated one points to the commit. The light one just points to the tree, the same tree that commit points to. But
Yeah, because you don't want that commit. That's interesting. Cool. I do think, by the way, that trees can point at other trees like subdirectories, but I'm not 100% sure. I think that's how it works. Anyway, the important part is we've went through like the entire commit flow, add commit flow, and we know everything. Like everything that's important about this folder, we know how it works other than refs. So let's figure out refs now because that should be pretty easy. What are branches? That's a super common question. Sometimes people like to trip up people about their Git knowledge in interviews and whatever. Pointer's pretty simple. Pointers to commits. Let's look at that. Git, refs, heads. Heads is in, if you did CS like 101, it's like a head of the Turing machine. You know what I mean? Like the part that reads the characters. I think that's a source of head. If we read it, we're going to see, sort of unsurprisingly, a hash, like an object. What is this object? Well, we know what is this object. It's cat file. Oh, I did cat file. That's not going to work. 29df. It's the commit object. What happens if we check out a new branch right now? So git checkout -b dev. Unsurprisingly, we have a new ref called dev, and if we read it, it's going to point towards the same hash. So instead of main, let's read dev, pointing toward the same hash. So the pointer is like they both point in the same direction. And now there's a question: when we commit, which branch will sort of like move forward and point to the new commit?
Someone said the one that you're on.
Yeah, how does Git know which one I'm on? Conceptually, you and I understand that I'm on dev right now because I checked it out. Here's another layer of the onion that's really, really simple. It's whatever this file says. So there's a file called head. Whatever this file says, this is where you're checked out right now. And this is like the head of the machine that's going to move with you. Again, if you learned like Turing machines, it's going to move with you alongside the track. Sorry, I did a CS 101 in Hebrew, and now I realize it's way difficult to translate all the terms on the fly. So I hope it carries. And if I check out, unsurprisingly, if I check out main, you'll see that head is changed to main. And then if I check out dev, you'll see, unsurprisingly again, it changed to dev. Now I have a question. Show of hands. Who among you saw the very, very scary, error message or warning, I guess? You are in a detached head state. Like you're using Git and you're checking out something and maybe you're copying a command for somewhere, suddenly it's telling you you're in a detached head state.
You can't see everyone on the camera, but there's plenty of hands up.
Oh, okay. I'm seeing like a couple of tables. So that sounds scary. Like, what the fuck, computer? I'm using you. I pay for your power and internet, and you're telling me you're going to cut my head off? What the hell? But now that we know what the head file means, we realize the computer is not making threats at us. At least not yet with AI. It might be changing pretty quick. It just means that the head doesn't point at a ref, but at a commit directly. It's detached, since if you commit, no branch will like move along with you, and you'll sort of have to remember that hash. So again, if I check out git check out this commit specifically and getting this like very, very scary error message, what I sort of want to imbue you with after this lecture is that Git can't throw any error message at you that you can't understand now, because you know how it works, right? How it works like under the hood. So you're in a detached head state. You can look around, make experimental changes and commit them, and you can discard any commits without impacting any branches by switching back to a branch. And what they say is that normally you probably want to create a new branch to retain the commits you create. And you can turn off this advice. I don't recommend it, even though I know what it means. It's good to like know that that's where I'm at. Yeah, another cool trick. This is not like an internal trick, but it's still useful. Git checkout minus just gives you back the latest branch you were on. Pretty useful. Oh, and of course I forgot the entire thing I wanted to show, which was when you're checked out at a commit, instead of this saying like refs, whatever, it's saying the direct hash of the commit. Now, when I get back, it says, oh, it's actually pointing to a reference. It's this reference. Let's create a new file and commit it on dev. So we had hi, let's do by into Bob, git add Bob. Now you know what's going to happen, right? There's a new blob here. This is not surprising. This is the content. Like there's a new hash. And we can sort of know that this is 0917, right? 0917, because we echo by into hash object and we see that it's actually this one, 0917. So this is the same as same thing we saw as before, not surprising. Git add, did I add it already? Yeah. Git commit -m Bob. Oh, I shouldn't do that. Cool. And let's look at the branches files. Right? So cat.git /refs/heads. So we have two of them, right? We have main, that's on 2.9 whatever, and we have dev, that's on E6, which is a new hash. And the thing we can do here, which is really, really nice, is we can implement git log, now that we know how this works, or git show, I guess, on our own. So let's do it. Git cat file, right? Using this internal command. Let's read the content of this file, but I don't want to type it out. So like this, I don't want to copy this. I want this command to always work. So what I'm going to do is I'm going to do like this command substitution here. So if you're not familiar with the syntax, anything that happens inside this dollar is going to happen and then replaced. And we're seeing the commit. What's new about this commit compared to the old one? It has a parent. So the first one was like the first commit. It doesn't have a parent, but this one has a parent. So it points at the new commit. Now, I can go even further, right? I can grab the parent line, and then I can grab its hash, and then I can implement a command that does git cat file minus p on this whole thing, right? Reads this entire thing, and then does that again to read like the parent. Oh, I messed up the syntax. Oh no. I was like, I had so much bravado and it didn't work. Let me consult my notes. Okay, of course. This is the hash of the parent, and now I do git file on that. That's what I meant to do. Yep. Cool. I got to the first commit. St. Louis is acceptable, as we all agree. Woo! Shifting back to the slides again, just in case this was a little bit complicated.
The audience.
We have objects, and then we have refs. These are just pointers to commits, and I can check out multiple of them. When I check out a branch, for example, testing, the head moves to that branch, and when I commit on that branch, that's what moves forward. I can check out head again, then go back to a different one. There are lots of examples with like these charts online. So let's say we start here, we check out issue 53, then we commit on it, then we check out a different branch, and then we can even merge, which updates stuff. And this stuff gets pretty complicated pretty quickly, but this is how it works. You have objects and you have refs. Just before we close out this part, I want to quickly show you how it works with remotes, right? Because we have the benefit of being on the server as well here on the server side. We can go to the remote and see what's happening there. Unfortunately, here, nothing interesting is happening because we haven't pushed anything yet. So let's push and see how it works. Git push origin dev. Important to note, now that you know how everything works in Git, you can read this output. I don't know if you ever took the time to actually read it line by line, and you can know exactly what it does. So it's enumerating objects in your objects folder, right? Objects meaning things you have in your .git/objects. And it's counting them. Then it's compressing them, very impressively doing delta compression up to 10 threads, blah, blah, blah. But it's just compressing objects. Then it's writing objects. In this case, it's not writing it to a network pipe, it's writing it to a file pipe. So it's just literally copying them. Then telling you how many objects it moved around. Total 6, 0 reused. That makes sense, right? Because this is a first time we're pushing to this remote. Telling you where it pushed to. This whole part is just syncing the objects folder. When you push, you just take all the objects you have and you shove them to the server. And this part is syncing the refs. It's like, oh, there's a new branch. The server wasn't aware of it. Named dev here, so it's named dev there as well. If you look at the remote repo, you're probably not going to be super surprised. Inside objects, we just have like our objects. Oh, I didn't delete the hooks from here as well. One second. Yeah, go into servers and delete random stuff. This is very healthy advice. So you'll notice we have the dev ref. It's the same as you have it, pointing toward the same hashes. All the hashes are the same. You are missing main here because we haven't pushed main yet. But, that's how it works. If you look locally, though, you'll find that you have, now I'm at the local repo, right? On the right side is the local repo. You can see pwd, local repo. If I read the .read refs, I have remotes here. So I only have dev, right? origin, according to my knowledge, and .git basically means according to our local repo knowledge, doesn't know about main yet. That's true. Like, we haven't synced it. We can definitely git push origin main as well. And now it also has main, according to our knowledge, because it was like okay with accepting this. Now, someone else may work on main and push stuff into main and then will be out of date. So, what we have here is according to our knowledge. This is where you think remote is at. When you run git fetch, like with -" or whatever, you basically sync the remote and local, but you don't change anything locally. When you run git pull, which is what I normally run because it's very pragmatic and like useful, you run git fetch, which gets all the objects from the server and all the refs from the server and puts them in the remotes folder, and then merges the current branch you checked out. So it's just a convenience command around two totally separate actions, fetching all the objects and the refs from the server, and then trying to merge your local branch over the remote of the same name. And it doesn't have to be at the same name. You have like a ton of flexibility here, which people tend to shoot themselves in the foot with. That's how it works. And if you look at git branch -a-v, we're not going to go through this exercise because it's going to take a little while, but now that you know how this works, you know you can implement this command, right? This is like so easy. It's like, oh, this is like ls on this folder, right? And then for each one, you like write a line. The one that has head, you go read head, and the one that has head is the one you put the star on. And then you grab the blob, and then you grab the commit message, the first line, and you just write out that line. And then you go and do it again. And then you do it for remote as well, the remotes folder. So this is like a command that you could implement right now, just because you know how it works. There aren't any more layers to this onion of how branches work. And I think this, like, in my opinion, this is a system that is very elegant. Everything talks together to be efficient, to make sense, to be very simple, to, in a very Linux style way, rely a lot on mathematical certainty of hashing, on files, on very pragmatic decisions, stuff that you can debug locally very simply, and a very elegant solution for like distributed systems to sync together pretty efficiently for the job it was created to do. I don't know how many of y'all had the displeasure of working with centralized version control systems, like, SVN is like my top one. I've used it for years. It's way worse. This one's way better. It's like not even close. So this is how branches and also the remote aspect of it works. Before we very quickly go over how git log works, any questions?
Yeah, we got one. 1 second.
Shoot.
So I'm not really a coder. I'm more of an idea guy, and been working with AI bots and learning all this stuff. I came here because I wanted to meet people, but also I wanted to learn about this because I've had issues where I try to do a checkout, and my bot wrote something, and I copied it, and it erased an entire project. And I'm not sure. I wondered if maybe you could tell me how that can happen, like if there's specific destructive things that I should watch for.
So first of all, hi, welcome. Deleting your entire project is something that everybody in this room did. They will tell you they're not, because they're not vibe coders and they're engineers, but they did it. They just did it when they were young. It happens to everybody. Don't worry about it. When you run the command checkout, what you do is you take a version from the versions that Git is tracking, and you bring that up to your working like folder. Very practically, I would never let your agent do that until you understand these commands. I will just not allow it to run Git commands. If you're using Claude, you can add it to a deny list. And what I would do is if you're just working locally, if you're just working alone on your own project, you can get by without multiple branches or whatever. Just remember to, whenever you do a change, commit your changes and then push them to GitHub. And then even if you lose the computer you're working on or whatever, you have like a versioned sort of check a log of all your work. Branches are usually useful when you work with a team, and then every developer has their own like branch, and they're working on a feature, and then they delete that branch when they're done. It's like a more collaborative sort of thing. Checkout can be destructive. It's editing local files on your disk. If you haven't stored them anywhere else, it can very easily yeet all your project. Which is why you got to be careful when you run it. But if you commit early and often, you can always like get back to a situation where you were happy with. So my advice to you is to get into the habit of committing early and often. I'm doing it all the time. Like git commit, git push are some of my favorite commands. I just type them. It's almost by instinct. Like every time I switch windows back to my terminal after I finish editing a file or whatever, or telling Claude to do it, I'll just do git status, look at what changed, add it, and commit it, and then push it to my working branch.
Thank you.
So that's like a good general direction. And also, my heart goes out to you. It's not a pleasant feeling, but
All right, we got another one.
Learning that's worth the price of admission.
Hello. I assume you can hear me?
Yes.
Excellent. This is somewhat of a beginner question, given that I've only mucked around with Git a little bit for just storing random code projects. But you're telling me, just as a test of intuition, that essentially all of these objects are just being referenced by those tree things, all these blobs. So when you're pushing somewhere else, it'll only send the blobs that are relevant to something as it currently exists, or all past versions of it.
Great question. It stores all versions, and it not only sends the blobs, it also sends the trees and the commits themselves. These are all objects. So every commit you've written points to all the trees, all the tree it contains, and the tree points towards all the blobs, all the like code files, directories, whatever. The beauty of this system is that you sort of decouple the references, the names like of the branches, main, dev, whatever, from the content. And because the objects have this like hash, you mentioned that you're a relative beginner, so I'll just say that hash is a function that takes the content, and given the same content, it will always output the same hash. It's not reversible. You can't figure out from a hash what's the content, but the same content will always give you the same hash. When you send an object over and all these objects are pointing towards one another, that sounds like a recipe for, but the references, the thing that pointed at that thing no longer exists, and then the entire house of cards fall down. Because these hashes are like self-validating and they point towards one another, you can't change history. You can just add more objects on top, pile more stuff on top of the file, on the pile. Because they're compressed, they don't take up a lot of space, so that's totally fine. Turns out it's a more efficient way to store things than trying to store the diffs, trying to store like what changed in each version. It's actually just better to store the entire file every time. Of course, if the file hasn't changed, because you hash it, you get the, again, another super smart observation. Most files don't change over most versions, right? You change a file here, you change a file there. Normally, you don't change all the files all the time. So what ends up happening is you hash it again, and then you go to store it in the objects folder, but it's already there, right? If the content is the same, then the object is going to be the same. Hashes have this nice mathematical sort of property that it's really, really rare to have collisions. Even though they are a limited, there are a limited number of values a hash can be, because it's a limited number of bytes. In practice, you'll never run into two files generating the same hash. It's just not going to happen because it's a really large number. So you don't stupidly save the same file's content every time. Also, if multiple files have the same content, they end up with the same blob as well, which is nice. So it does sound on the surface not like too simple to work well, but it's actually the most efficient system. It's better to, of course, this is a generic system, right? So there might be cases where storing diffs is slightly better. And there are, to be fair, second order optimizations that Git does that we're not going to get into. Like sometimes it packs the objects folder for really old commits, into like these big files that make more sense in the history. It does like, sort of cold storage, if you will. But generally, yeah, you just store all the files, all the trees, and all the commits in objects, and you just take this big pile of objects and you throw them into the server, and it works really well.
Oh, I think there was a follow-up here around how does Git produce the latest state of the file when you go check out a specific commit, if that commit doesn't necessarily reference that blob directly? Is that kind of the question? Yeah. Yeah, how does it reconstruct everything from this big old pile, basically?
So you have the ref, right? You go and you type git checkout dev. And I'm going to share my screen because I think it'll be useful to answer. And thanks for all the questions, by the way. You don't know how, maybe you do know, how stressful it is to be in a lecture like remotely, and then you're like questions, and then nobody asks anything. So at least I know you're real people and you're there. You know what I mean? So that's really nice. So when I go and I do git checkout main, right? What I actually am telling Git is I'm telling Git, please read the file that is under main, right? So in this case, it's this one, right? Please read this file. It goes ahead and does that, and then it looks at tree, like literally does, well, not literally, but you can imagine it does grep on the tree line, like it finds this, and it says, oh, okay, I need to check out this tree. So when what is there? Okay, let's read it. Cat file minus p. So what's here? What did I miss? Again, I did cat file, old habits. That will not work. Git cat file minus p, this one. So now what I'm doing is I'm reading the tree, and it tells me, oh, put up this file, ls6t, with this content, with those permissions. It knows it's a file because it's a blob, right? With those permissions, like copy the content into here and just write it out. So it literally does git cat file minus p b14d into alice.txt, right? And it does that for every line in this tree. Now, if you look at dev is just slightly more interesting, right? So if you look at dev and we do the same exercise, we'll see that this git cat file minus p, this one is pointing towards this tree, right? Git cat file. And again, you can do this. This is not like a magic command that I have. It will just see, oh, it has 2 rows, so I need to write 2 files with this content and this content. This is the same as before, right? So it points towards the same blob, which is sort of a useful trait of it, right? B14D, B14D. It's the same blob because we haven't changed alice.txt in this commit. And this file has this blob. So the way, when you do checkout, the way Git figures out what to write to your local file system, it doesn't reconstruct like smartly in an intelligent way. It doesn't like go into history, calculates the differences, and delete specific rows, and then add specific rows. It might seem like that because the diff view, it has like the red and green lines, so you think it's calculating differences or whatever, but it's actually way simpler. It just take the object, write it to disk in this place. This is what the tree basically says. It's a snapshot of your working directory at the time. Of course, there are exceptions. Like if you have a git ignore file, it will not be added to the stage, and therefore it will not appear here when you eventually commit it. And when Git writes files, depending on your configuration, sometimes it does contain line endings, sometimes it doesn't. Like if you're working cross with someone who's working on Windows, This is a setting that you may run into, that the line endings are different. So you can configure Git to sort of ignore line endings and just work according to your operating system. Where, I'm using a Unix style system here, of course, with my MacBook. So there are a few steps before it just takes the object and writes it to disk. But that's basically what it does. It takes the objects and writes it to disk. So that's how it works. I hope that answers the question about like the reconstruction. But it's also important for me to belabor the point that this system is really simple. It doesn't like do intelligent calculation. It just relies on its very elegant design. Now, in the interest of time, I'm going to go really quickly on Git log, and then we're going to get to the fun part. How does that sound? And if there are any questions, people can ask me during the fun part. Okay? Or are there any like
say that one more
questions?
time. There's actually lots of questions going up all over the place.
All right.
Yeah, I think let's do that. Like, I think switching to the CTF at this point is a good idea. And then I know that not everyone is going to be participating, so we can probably squeeze a few questions in between then while people are working on it.
Sounds good. So speed run of the rest of the lecture, because I think it's the back half of it is less important for what we're trying to do. I just wanted to point that there's a command called git log, which is super useful. And there's a nice thing about it that now if you read its output, you can implement it. Again, you take head, git log takes head. Whenever you do something in Git and you don't pass a parameter, usually it means that sort of by default, it will look at head as the parameter. And you can see it has the commit. It says the object is commit, then it's hash, then all the references that point to that hash, so sort of a backwards lookup of all the references that point to that commit. Tells you the author, formats the date nicely, right? Because the object has the date in like Unix time, and this is like human output of it. You can see here I'm in like Pacific time, and the message, and then the next one after it. How do I get the next one? You remember we literally implemented this already with the this command, right? Where we did like grep parent. So we sort of implemented this already, right? We were able to, you just recursively type git cat file until you reach the end. This is how git log works. And just for the sake of doing things that do branch out, sorry, old note. It's not master anymore. That's not allowed. Here, let's echo hello into Eve. I'm main now, sorry. Let's add it. I'm not going to track like the repo on the side. Y'all already know how it works. It created 3 new objects, one the blob, one the tree, one the commit itself. Eve. And then if I type git log --1 line --minus graph, am I going to see dev or am I not going to see dev in this output? I'm not, because when I type git log, it's sort of by default putting head here, and this points towards main, but main doesn't point toward dev. What I can do though is I can give it both like points to start with, and then it'll recursively go back and like find the common parent and only print that, which is again another classic like interview question, right? Oh, go over a graph, a direct acyclic graph, which is what a Git history really is, and print it out. And if there's a branching, put these like little, these little symbols here that sort of simulate that this commit, the 29F where we started, is the parent of both of these. And yeah, that's how Git works under the hood, which is pretty useful for understanding Git in general. And then when you face commands like git merge and they don't work and whatever, you have a little bit more understanding of why it didn't. Instead of going through all these slides and trying to explain everything here, the difference between Git, rebase, whatever, all the workflows, and how to solve conflicts and all that stuff, we're we're just going to quickly explain merge versus rebase and what is merge, because a lot of people are afraid of this part, and then we're going to jump to the CTF. I think it's going to take like just a couple of minutes. So why is integrating work hard? Here you can see master is an ancestor of hotfix. C2 is a parent of C4. If you integrate all the changes from hotfix, you can just move master forward. You can just make it point to C4 and you'll be good. Here, though, on the right, if I just move master to C5, I will lose all the work that was done in C4. There's a fork in the history. So Git does the very simple work of finding the common parent, data structures and algorithm question, recursively go back and find what's the first node that both share as a parent, and create a new commit where you have all the changes from both sides. When you rebase, you don't do that. You keep the logs linear. You go back and you sort of replay all the commits you've done. History is altered, which is basically means you create new objects and you sort of discard the old ones eventually. With merge, you'll have more commits and sort of a complete log of everything. The work log will be non-linear, meaning when you type git log -- graph, it's going to show like a ton of branching and whatever. Generally, I'll say if you're a beginner, Git merge is the way to go, because there's less chances for major fuck-ups. You never overwrite existing branches. But it does have the cons of having a wide tree and a lot of useless merge commits that don't actually mean anything. Rebasing keeps the logs linear. You can edit messages, and basically gives more tools for each developer, but there's potential for destruction, because when you push your reference to the remote, when you push a branch, you have to push with force, because you're overriding what this branch is pointing towards. You're not just adding more stuff to the branch. And if you don't know what you're doing, you may destruct stuff, or if you're working with a team and the team doesn't know what they're doing, they may not understand what's going on, and they might still do merge commits and it won't work. The important part is team rules. Whatever your team does, stick to that. You can't have both at the same time. But I used to do a lot of work in open source. I was the lead developer behind the project called Infection Monkey, and I did some kernel support and a lot of Go work. And you'll see that in serious open source projects where the history is actually important, and being able to run git bisect is actually important, like finding where a bug was introduced in the history. Rebase is the way to go. And in all the teams that I've managed, that's the way we went, even though it was kind of painful for the team members to go. Once they learned it, though, I've never had a team member that switched back in their other projects. So another reason to think about it. If you're working just on your own and you're a beginner and you know this is a personal project or a side thing, just doing merges is okay, and you can always switch later if you want. That's at least my opinion, of course. This is a very religious thing. People take it very seriously. Cool. You can't have both, though. Just be careful, because it causes conflict hells. You have a nonlinear and rewritten history, so finding the common parent of a something becomes impossible, basically. Again, like I said, my thought is rebasing wins, but that's just my opinion, man. Cool. There are other things here about doing workflows and trunk-based development or whatever. This is more like team management stuff. And best practices. I don't remember what was the name of the gentleman who deleted all his project, but here's what I said: commit early and often. You can always rebase to delete useless commits, but I always do those. Like, I'm going out for a coffee with someone, like a one-on-one, git commit -m whip, get back to it later. You go into a meeting, git commit -m whip, I'll get back to you later. End of day, I'm packing up my laptop and I'm getting on my bike. There's a chance someone's gonna run me over. Git commit -m bike, get out of there. Another thing is don't break the build. If you do have CI, try to not break it for everybody. This is just good team practice. Writing good commit messages. This is, funnily enough, more important in the age of AI. If you have good commit messages, then your agent will probably have good commit messages as well. And then over time, the agent can very easily look back at history and find where bugs were introduced. This does tend to happen, though, where you start like with very nice commit messages and then you end up with like, especially if you have a lot of them. But I've found that it's useful for me to still write them. I still write them by hand sometimes, although, again, AI agents are taking more and more of that work. I'm not going to go through how to write good commit messages. And of course, to get good at something, you got to practice, practice, practice. So let's get practicing. We have prizes, I think. Levi said we have prizes.
Yes, we do.
Very, very cool.
All sorts of stuff.
Nice. So we're going to do a capture the flag challenge. A lot of you mentioned you already know what this is. There's all the instructions here. What I would like us to do, if we can, if y'all can, is to like pull out of your laptops and let's try to do the first step sort of together-ish. Also, especially for you Americans, I've discovered that my server is in Europe and it will be very slow. So I've set up another server just for this session. So the address is going to be kind of different. So if you just follow the instructions on the site, it's going to be a little bit slower. So how about everybody pulls out their laptop and we get started with a challenge?
I think people are geared up.
Awesome. So we can start.
I think
Please go to my website, mrnice.dev. It's nice because Nehmad in Hebrew means nice. Literally, like that's literally my name. Like if I translated my name to English, it would literally mean nice gift. So imagine just walking around with that. Your name is literally like nice gift. Apparently my parents didn't connect the dots fully when they named me, but that's okay. So a capture the flag challenge is all about finding all the flags. And if you find all the flags and you give them to like Levi or me in a text file first, you win. And if you give them second, you win second place, etc. You need a web browser like Chrome. I assume you have one installed. You need an SSH client, so you'll be able to type SSH. And you need a terminal. I don't know what terminal you're working with, but if you can render Unicode characters correctly, it will be good. If you have all these three things installed, you should be ready. And there's some advice here on how to install the terminal, whatever. If you've never used the terminal before, don't worry, you should be able to do it. And you're going on a game server with the rest of the people in the room, so don't try to sandbox escape and destroy it. I assume you'll be able to if you really, really try, but that won't be very nice for everybody. It's a Linux box. Everybody's going to get their own box, of course. Everybody's going to run in their own Docker. With the Z shell as your shell. If you're used to Bash, it's pretty similar. If you're used to Windows, it's going to be kind of difficult, but you're mostly going to type git commands, so you should be fine. It has the git plugin, so some useful shortcuts. I recommend you install it. I wouldn't be able to live without it. You have fuzzy finder, so you can type Control-R and you'll have fuzzy history matching. And all your favorite text editors. So Vim, if you don't know how to use Vim, you can type this command to change it to Nano. You have Emacs, you have Nano. And everything you need is installed on the machine. You don't need any other external tool. And very, very importantly, and I'm going to stop here before we start. Yes, an AI agent, if I tested it, if you point it at this CTF, it wins it. So there are no prizes for someone pointing their Claude at my server and winning. That's not the point. The point is for us to do it with our human flesh hands. And instead of tokens, burn calories, right? So don't... There's no point. There's no point in letting the AI win it for you.
Do we have any
like here to
specific
learn.
rules around AI usage? Like, is this a don't Google anything as well, or is this a just don't use an agent to solve the solve the challenge?
I mean, you can use ChatGPT for searching and where you would use Google, but it's important to know that I think if you ask, let's test it. You know what I mean? Just give me a second here. How? Oh, no. Let's see if it works. How to solve the CTF? Make it better on Mr. Nice. It gives you answers, right? So you can ask it about Git, but don't ask it how to solve a specific level. Just use it where you would use Google search, right? How do I like Git commit some flags or something? And I do sort of, I would suggest you try to just use like Git help commit and read the documentation before reaching out to AI, just for this case, not in your day-to-day work for sure, but just in this case. So like, sort of the friction is the way you learn, in my opinion. But this is all honor system, right? There's no, it's not like a real competition. Fine. Cool. So go to mrnice.dev/CTF, click right here to start, right here. It will open the first level, which is a clone. This CTF is separated into levels. Here are all the levels. Ignoring OWASP CTF1 and OWASP CTF2, these ones are specifically aimed at security professionals, and I did them for OWASP CTF. So they are not part of our competition, but there are cool points, extra credit if you get them. But these are all the levels. You can click to navigate. Right? Pretty cool. So this is like your level browser. When you finish all the levels, you win. I know you can do it, etc. Each page contains the information about the stage, and at the bottom, by the way, before you ask AI, some hints that might help you to, to find the answer without just giving it to you. So to get started, you need to connect to the game server. This is the command that will work, but put you in Europe. Player at CTF mrnice.dev. But of course, America is better than Europe, right? Freedom. I don't know. I'm just getting my green card, so I'm really trying to get on record, saying all the right things. But I think you should be able to navigate to CTF US .mrnice.dev. I hope this works. Wait, maybe the address is different. Wait. Maybe it's make it better US. No. Yeah, it is a CTF US. SSH player at CTF US at port 12345. I hope this works. If not, you can fall back to the original one, which is SSH player at CTF .mrnice.dev, and it boots you onto that server, hopefully.